clustering. And we're going to do a similar problem, except now with this data set. We're going to find the clustering into, let's see how many groups we can find. So another way to do it is the following. Let's think about this. Let's think of the two closest points. It would make sense to say that these 2 points that are the closest will belong to the same group. Maybe yes, maybe no, but it's a sensical thing to ask, right? So let's go on that statement. Let's say these are the two closest points. So these two are going to be part of the same group. Now, what are the next two closest points? Let's say it's this 2. So these two belong in a group. And we're going to keep going in this direction. The two closest points are these ones. So these two belong to the same group. The two closest points are these ones. So now what do we do? Well, we just join the two groups. So now it becomes a group of 3. The two closest points are these two. So they join like this. The two closest points after that are these two. So we join the two groups, the group of 2 and the group of 3 into a group of 5. And then the next pair of points that are the closest are these two. So we're going to join them. But let's say that's just too big. So we have maybe a measure of how much is too far. So we stop here. And that's it. That's hierarchical clustering. It's pretty simple, right? Now again, there seemed to be a human decision here, right? Why did we decide on that being the distance? Or for example, why did we decide on 2 being the number of clusters? So we can make this decision. But let's actually look at an educated way to make this decision. So let's answer this question. How do we decide the distance or the number of clusters? So a way to do it is by building something called a dendrogram. So what we're going to do is the following. We're going to put our points in a row over here, 1 up to 8. And then in the vertical axis, we're going to graph the distance. And I'm going to show you how. Let's pick the closest 2 points, which are 4 and 5. So we join 4 and 5, and we join them over here. And this is not up to scale, but the height of that little curved line between 4 and 5, let's say it's the distance between 4 and 5. So we join this 2, and then we go to the next 2, which is 1, 2. And so we're going to join 1, 2 here. And we're going to join them in the dendrograph in the right. And again, assume that that height of that little curved line is the distance between 1 and 2. Now we join the next pair, which is 6 and 7. So we join 6 and 7. And again, the height is the distance. We keep going, 6 and 8. So now we're going to join 6 and 8. How do we join them? Well, we join them like this. The group of 6, 7 and the group of 8. And the next group is 3 and 4, 5. So they get joined like this. And now the next group is going to be 2 and 3. So we join the group corresponding to 2 and the group corresponding to 3 in the dendrogram. And notice that the dendrogram goes up because these distances increase. So every time we make a new join, it's higher than the previous ones. The next ones that we join are 3 and 6. So we end up joining these 2 trees like that. And so that's it. We have a lot of information about this set in this dendrogram. And now how do we decide where to cut? Well, let's say we cut over here at a certain distance. And that gives us 2 clusters, which are this one, 1, 2, 3, 4, and 5. And this one, which is 6, 7, and 8. So notice that we made the decision on cutting based on how much a distance is too far away or how many clusters do we want to obtain. Let's say that we want to obtain 4 clusters. So we cut at this distance over here, which gives us 4 clusters. The cluster formed by 1 and 2, the one formed by 3 by itself, the one formed by 4 and 5, and the one formed by 6, 7, and 8. So again, these decisions are taken by a human, but think about it again. Let's say we have billions of points. And let's say that they live in a 1,000-dimensional space. It doesn't matter. The dendrogram is still a 2-dimensional figure, and we can easily make decisions on it. So again, a combination of a computer algorithm and some smart human decisions, it would give us the best clustering. And that's it. That's hierarchical clustering in a nutshell. Hierarchical clustering.